Hello everyone, so in this video I'm going to talk a little bit about this capacitor bank. Okay, we have a general arrangement like this. Suppose this is a consumer, is a welding shop, or it's a pump house, then which are having inductive load, and as per the provision of MSCRC, in our case I mean the State Electricity Regulatory Commission, in those consumers which are having highly inductive load like a welding shop or a pump house, then they are required to install a capacitor bank at their premises. Why? Because I'll tell you that also later. So the general arrangement will be like this. Suppose we have this 25 kVA 11 kV by 0.43, which is a practical thing that we find in rural areas. Most of them have 25 kVA transformer, and it is not only you who will be taking power from this transformer. You have other consumers also drawing power from the same transformer. And this capacitor bank is actually to stabilize the voltage or to regulate the voltage, because every time you have an inductive load, every time you run your welding machine or you run your motor, your pumping water pumping motor, then it is going to draw a lot of current from the transformer, and due to which whenever current is high in the line, the voltage will drop so as to balance this kVA. No, I mean that is a different topic altogether, but just to general information that any high current will dip the voltage, and if this welding machine is operating the whole day, then the voltage fluctuation also will be whole day. And this and all those consumers which are connected or drawing power from the same transformer, they have the electrical appliances like a fridge, they have a TV. All those digital circuit will be affected, and sometime they may not function also, and they may get damaged also because of the voltage fluctuation. So in order to avoid this, the utility, as per the instruction from MSCRC, will instruct the such consumers to have a capacitor bank installed at the premises. Okay, so the question is that where to install the capacitor bank? Is it like this, mean after the meter, like you see in this circuit, which is of course the correct way, or before the meter? All right, technically speaking, mean there is no problem we install here or here, there is no problem, but it has to be installed this way. Okay, because what capacitor bank does is that it provides the reactive power, the reactive energy required to establish a magnetic field, which is further required to have a constant voltage or a good voltage regulation. And suppose you install it here, then what happens? Let's take the first case. You install it before the meter, then, and suppose you are not you are not connecting any load, I mean there is no load, then what happen? In spite of the fact that there is no load, there will be exchange of energy. I mean that is the property of a capacitor. It dissipate, or it charge and discharge. Okay, constantly charge and discharge energy. And if there is no load, then the exchange of energy of reactive energy will takes place between capacitor bank and the source and the transformer. In that case, there will be current between the, I mean depending on the rated current of the capacitor bank, there will be current between capacitor bank and the source. Okay, and if we install it before the meter, then this current will not be passing through the meter, and this that's why the reactive LED of the meter will not blink, due to which whatever the meter records, it will record only the active and the apparent power, because active and apparent in that case will be almost equal, and that's why the meter power factor indicated also will be very much near to unity. All right, and it doesn't have an impact in a state like ours, because we build them on active energy only, not on reactive energy. I mean some other states which are billing those consumers, or which are having this power factor penalty, this and that, then it is required that they have their this one installed like this. But if the consumer is built on kVH, then it is very much essential that they install the capacitor bank after the transformer like this, because if install like this, then what happened, the meter will record everything. Okay, whatever reactive energy or reactive current that will be flowing here, if there is no load in load connected, or you are not running any motor or welding, the current will be there, and this current is mostly reactive, due to which the only the reactive LEDs will blink, and nothing blinks in the active LEDs. Okay, so it will not have an impact on the consumer also, because you will not be billed on kWh, you will not be billed on, I mean, you will not be billed on apparent or reactive, you will be billed only on active. So even though the LED blinks or there is current, I mean that current is reactive, it will not have an impact on the consumer. All right, so my intention is that you should always connect your capacitor bank after the meter. All right, of course, for a state like Meghalaya, you can install here also, before the meter also, or after the meter also. It will not have an impact. But for general, or for uh, for the information of all, or to have a very comprehensive connection, you should always install your or connect your capacitor bank after the meter, like this. All right, so this is the correct way to install your capacitor bank. Okay, I think this also clear your doubt where to install. Is it before or after? All right, so thank you.